Hi students, very good evening to all. So I am here to give the preparation strategy for TRANSCO, Genco and DISCOM examination, particularly for induction machines. Before we start with our preparation strategy, so let me introduce myself. I am Dr. Ahad. So completed my Masters and PhD from NITK Surathkal in Power Electronics and Drives. And I am associated with our ACE Engineering Academy since 2008 onwards. And I am dealing induction machines here in Hyderabad and in other branches the remaining AC machines. So I am standing before you to discuss the preparation strategies for your Genco, TRANSCO and DISCOM examinations. I am not going to take a lengthy discussion on this, a short and crispy I am trying to explain. So the first and very important thing is, before you start your preparation for this Genco, TRANSCO, DISCOM, first what you need to do means you have to understand the exam pattern thoroughly and pace your exam preparation accordingly on the weightage of each subject. As this Genco, TRANSCO and DISCOM examinations are totally different from the other competitive examinations like GATE and engineering service, first of all you should understand the pattern. First you need to understand the syllabus, and first of all you should get ready with your examination. First you have to set your brain or mind in such a way that you are trying to give a Genco or the statewide competitive examination. Please don't mix this preparation with other competitive examinations like GATE and engineering service or other PSU examination. So this state-wide examination is totally different from other examination. Please try to make a separate preparation for this, or at least try to make a mindset that you are preparing for this Genco examinations, right, or TRANSCO or DISCOM examinations. So here, as you can see, before you start your preparation, so don't make a complex preparation. What is the meaning of a complex preparation means? As I told you that you should not mix your preparation with other competitive examination. Please focus on your statewide competitive examination and please set your mind only to that point, statewide Genco or TRANSCO DISCOM examination. First point to be remember is you have to set your mind according to your preparation, that is for this statewide competitive examination. The next step is referring to the standard textbooks. So most of the students, what they try to do means, so in out of curiosity or in other way, out of some unknownness, what they will try to do means they will try to put more textbooks and they try to procure more textbook for the preparation. So this will not only delay your preparation, but at the same time this will waste your time also. Please try to select the standard textbooks given in your BTech examinations or mentioned in your syllabus. So please try to refer only the standard textbooks. Now when I am talking about machines, then your standard textbooks are PS Bhimra. So we are having two books for PS Bhimra. One is Electrical Machineries, the other one is the Generalized Theory of Electrical Machines by PS Bhimra, and the other book is Nagaratan Kothari. So these are the two standard textbooks which we can use for referring, right, the material. In addition to that, if you want to solve any numericals, then you can go with the other textbooks like BL Thereja. So BL Thereja, I can say it is only for numerical purposes. Why? Because in BL Thereja, so the book has covered the numericals from all the universities across India. So you can find different numericals from that BL Thereja. So you can refer BL Thereja for numerical purpose, but theoretical for concepts you have to prepare the PS Bhimra or the so-called as Nagaratan Kothari. Then one more thing is, if you have joined any institute for coaching like online or offline, then please remember you can refer the material supplied by those respective institutes. For say in our ACE Academy, So we have taken all the care to prepare the material keeping in view of all the examinations. So for that we have referred many textbooks, the standard textbooks, both for concept and also for numericals and also for objective. And if you look into our material, you can see after each topic, each concept, there will be some numericals and there will be some questions given at the end in the form of classroom objective. If you are able to do that, you can understand the importance of that subject or the importance of that topic. So please remember, you can refer the material supplied by the respective academies. So why? Because the teacher has taken all the care. If I am talking about our ACE Academy, so we have taken all the care to prepare the material according to the needs of the statewide competitive examination. So if you go through this, so it is much enough for your preparation. The next one is, so just one second, next one is the revision. So revision is a very important concept which you need to go for. So for revision, what you need to do means, so you have to make a timetable. So revision doesn't mean that you go as you like. You have to make a timetable. So what is a timetable means? Say your notification has a release. Now you have not started your preparation, and say after notification you are having some 3 months. Let us assume 3 months. So 3 months means 3 into 30 will be having 90 days. If I am correct, for this Genco and TRANSCO, the students who have completed are eligible, or the final year students sometimes may be eligible. Say as most of the students are completed their graduation, so you will be having 90 effective days in your hands. So at least if you can take out 10 hours in a day, so 90 into 10 you will be having 900 hours in your hand. Say if you are having 10 subjects in your syllabus, let us say 10 subjects, then you can allot 90 hours for each subject. Now you please try to sit for some time and try to calculate how many hours you are having, how many days you are having, how many subjects you are having, then try to allot the number of hours for that particular topic or for that particular subject. Once you are ready with that, then allot for, say, first is you are starting with machines. In machines, if I am correct, you will be having mostly 4 topics. The additional will be the special machine. The first one is the transformers, the second one is the DC machines, third one is your induction machines, and the fourth one is the synchronous machines, and the last one is the special machines. So here the easy questions will be coming from your transformers and DC, and moderate level questions will be coming from your induction and synchronous machine. Then accordingly you sit. So for in electrical machines you are having 90 hours, and in electrical machines you are having 4 subjects, and at least if you allot something like 22 hours for each subject, then say for induction machine you are having 22 hours. So in this 22 hours, please try to mention day 1. So I will be starting this induction machine morning. So this time to this time, this topic I will be completing. So once you are done with the topic, then next day another topic, next day another topic. Like that, in this 22 hours you need to finish your induction machine along with your objectives, along with the short numerical questions which are being asked. So you have to finish. Once induction machine is over, then switch on to other machines, switch on to other machines, switch on to other machines. Once the induction and the total electrical machines are over, then you revise all the machines once again. Then you can say you are confident with respect to electrical machine. Once this machine is completed, then go for the other subject. Let us consider networks. Again, 90 days for that networks, again subcategorized into DC analysis and AC analysis. Again, allot the timing for a particular topic, then finish those topics. Now machines is over, then your networks is over. Before you start the third chapter or third topic, please see that you again revise these two. Again start the third subject. Like that, one by one, you have to complete the topics. So all the topics, all the subject has to be completed once. Like that, you have to revise the total subject once or twice. Then you have a question, sir, if you are having less time, what to do? Then you have to work more. Why? Because your criteria is to get a job in the state-wise. So please try to work more Why? Because if you can work more for this 90 days or whatever that 900 hours you are having, then your rest of the life will be extraordinary. You will be having a colorful colors, right? So please remember, you have to spend the toughest time for this 90 days or whatever the time we are having. If you spend the toughest time here, then the remaining life you can enjoy like anything. But you feel that if I'm not having the time, then you have to struggle the dark days in the coming futures. So please remember, you forget about the sleep, forget about everything, but try to keep your mind clean and also stable for this preparation, right? Then very important thing is solve the previous year question papers. So for statewide competitive examination, you may not have the previous year question papers as available in the market, but some of the academies, our academies are able to pull the previous questions. Please try to solve the previous questions, at least some 10 to 15 years. If not, whatever the availability is there, please try to solve the previous questions, right? The next one is make sure that you have to apply or you have to write the mock test. So most of the students, what they'll try to do means they'll try to skip this mock test. See, skipping the mock test is a foolish thing or foolish act. So I strongly suggest to my students, or I strongly recommend to my students that writing the mock test is very, very important. I saw out of my experience, many students, they will try to skip the mock test with a reason that they have not prepared. So even if you have not prepared any topic or even if you have not prepared any subject, please see that you do attend the mock test. Why? Because the mock test will make you indirect preparation. How? Means, say you have attempted a mock test. Then there is a question which you don't know from a particular topic. You try to answer that question, right? Say after the examination is over, you will get the answer script, right? Now you check your answer with that answer script or answers. If it is wrong, now try to analyze what makes you to do wrong, why your approach is wrong, what makes you wrong. Then you try to correct your method, try to correct your procedure. Then in the coming future, if any question is asked from the same area, you will not commit any wrong or you will not write a wrong answer. So I strongly suggest you means you commit mistakes, you do mistakes, learn from the mistake but don't repeat the mistake. So when you will commit mistake means when you write the mock test, if you don't know something, definitely you go for a wrong answer. Then it is something like you are committing a mistake. If your answer is not correct there, come out of the exam, then please try to see why, what makes my approach wrong, try to learn. So that is the reason the mock test is very, very important. Even if you are perfect in the subject, if you are not writing the mock test, then the chances of getting a rank or the job is very, very less. Mock test, more are the mock tests you write, more will be the confidence, more will be the experience you will get. So please remember, mock test is very, very important. Please try to make a mock test. So the next thing is, last and the final thing is, so before we go for the important concept, so whatever the preparation you make, right, please try to maintain a short notes. Why? Because this short note will be helpful for you, right, to prepare or to revise at the end of the course or in the last minute. So short note is very, very important. Try to make short notes. So finally, before we go for the important concept, let me tell. So what are the things you have to be careful? First point is you should make yourself mentally and physically strong. Why mentally strong means most of the student will have a inferiority complex that can I crack this examination? Can I get a rank in this examination? Please remember that no one is a born talented, no one is a intelligent. So if a person is getting a first rank, means he has done some hard work. So he has spent some nights to make his preparation strong. So that is the reason he got first rank. That is the only reason, that is the only solution for that. So there is no need to feel inferior, there is no need to feel that you are low compared to other. So you are strong, you can make the rank first if you make your preparation strong. So make your mental strongness, your mental ability strong, that you can do it. Physically strong, can you able to take this task? Yes, I can take. So make your mental stability, make your physical stability before you start your preparation. Once you are done with your mental strongness and physical strongness, then look into the syllabus of the particular subject. So what is the syllabus? What is the pattern? Why? Because exam to exam pattern will be different. Try to see what is the pattern. Get ready with the pattern, get ready with the syllabus. Don't compare this pattern with other pattern. First, pattern is very important, syllabus is very important. Then make a timetable. So please, from the day of notification to the day of examination, how many days are there, how many hours you can spend, calculate the number of hours, take how many hours you can get for a subject. Please try to allot a particular time for a particular subject, then prepare accordingly. So please, after one subject is over, before you go to the next, revise once. After second subject is over, go to the third, revise. Like that you have to revise topic by topic. So all the topics has to be revised completely and make the revision twice or thrice. Then when you are preparing, please see that you are making a short note. Why? Because the short note is very, very important. So this will help us for last moment preparation. Please remember that. After that, you have to solve at least the previous questions, and you should make yourself strong in making your preparation, right? So please refer to the previous. Then the third one is, the last one is, you have to attend the mock test. So these are some very important things which you have to follow while you are preparing for the subjects, right? Done. Right. Now coming to some important concept of induction machines. So I'm not going to talk the entire induction machines now, right? So first I'll try to see what are the major areas in induction machines. So first one is the concept of rotating magnetic fields. Then we need to discuss about the construction, the complete working principle, the steady state analysis, that is finding the performance parameters and the torque slip characteristics of an induction motor. Then the starting methods, why starters are used, then the speed control techniques, then the testing, then harmonic analysis, and lastly the single phase induction motor. So out of my experience, I can say for your TRANSCO, DISCO, or Genco, so I think this is the syllabus which we need to cover. Now I'm trying to take a short topic here, so I'm going to talk about the speed control of an induction motor. So let us see the speed control technique, right? So I'll be highlighting the speed control techniques, right? So what is the meaning of speed control techniques? So I need to control the speed of an induction motor. So what are the parameters available in the induction motor to control the speed? We'll try to see. If you look into this basic speed equation, that is NR is equal to NS into 1 minus S. By looking into this equation, one can say that the speed of this induction motor, that is NR, we can control by controlling the synchronous speed or by controlling the slip. So these are the two parameters by which we can control the speed of an induction motor. But instead of talking the speed control from synchronous speed or slip, we are going to discuss the speed control of an induction motor from stator side. So in stator side, what are the parameters we can control? By changing the applied voltage, by changing the applied frequency, or by changing the number of stator poles. So these are the three parameters we are having in the stator to control the speed. Similarly, when we are talking about the speed control from rotor side, so what are the parameters we are having to control the speed? One is the rotor rheostat control or the rotor circuit resistance control. The next one is cascade connection, and the last one is the EMF injection method. So these are the parameters from the stator side to control the techniques, and these are the parameters from the rotor side to control the speed. So but whenever we are talking about the speed control from the rotor side, please remember that so this rotor side control technique is applicable only for slip ring. Why? Because only in case of slip ring we have the provision to change the rotor circuit parameter, which is not possible in case of squirrel gauge. Why? Because in case of squirrel gauge, the rotor bars are permanently short circuited, right? Now let us see one of the method here. So that is nothing but by changing the applied voltage, right? Now if I just explain this by changing the applied voltage. Right. So if you look into the basic speed equation, what is that basic speed equation we are having? Nr is equal to Ns into 1 minus S, 1 minus S. So here in this basic speed equation, just if you can see here, in this basic speed equation, there is no like voltage term. This we call it as basic speed equation. There is no like voltage term. Then how can I say that by changing this applied voltage or the stator voltage we can control the speed? Why? Because this equation says that there is no like voltage term in this, how to control the speed. So for that, in addition to this, I'll be taking one more equation which you are going to see in the working principle, or which you are going to see in the induction motor. It is 180 by 2 pi ns s v square by R2. So these are the two equations which I'll be using to explain the speed control technique. One is the basic speed equation, the other one is this torque equation. With the help of these two equations, I can explain the total speed control techniques. Now let us see, by changing the applied voltage or stator voltage, how to control the speed, right? I'll try to explain that. Right. I'll try to explain that. Just a minute. Right. So I'll be trying to explain how to control the speed by changing the stator voltage. So as I told you that, say Nr is equal to Ns into 1 minus Es. This is one equation which I'll be making use to explain the speed control. One more equation is 180 by 2 pi ns s v square by R2. These are the two equations, right? Now let me take a simple example and I'll try to explain this speed control technique. Let us consider we are having a 3-phase induction motor. It is a 5 HP induction motor. The rotor winding resistance of this motor is say 0.1 ohm and the leakage reactance of this motor is say 0.85 ohms and the number of poles of this motor be 6. Now when I am exciting this motor with a voltage of say 400 volts at a frequency of say 50 hertz, the synchronous speed of this motor is 120 into F1 by P, so it will be 1000 RPM. And what is the speed at which it is operating means, let it be 950 RPM. 950 RPM at a slip of say 0.05. So this is the condition. So these are the numericals. So we have consider one induction motor. This induction motor is excited with a 400 volts 50 hertz supply and it is operating at a speed of 950 RPM, and let us consider it is driving a constant torque load. So it is driving a constant torque load. Now our intention is to control this speed. This is speed by varying the supply voltage or applied voltage magnitude. Now let us see, by changing this supply voltage or the voltage that is applied to the stator winding, how to change this speed. So if I take this torque equation, electromagnetic torque, that is equal to 180 by 2 pi ns s v square by R2. So here you can see we are changing only voltage. The remaining parameters, the supply frequency, the motor poles, the resistance and other parameters are kept constant. Other parameters are kept constant. If I take this torque equation, electromagnetic torque is equal to 180 by 2 pi ns S V square by R2. So from this you can see we are not changing frequency and poles. The synchronous speed will be constant and this will be constant. We are not changing the resistance, resistance will be constant. You can see the motor torque is directly proportional to S into V square. As you can see, the motor is driving a constant torque load. So this motor torque also should remain constant. If the motor torque should remain constant means S into V square should remain constant. Then from this S is inversely proportional to V square. Say by keeping the supply frequency constant, if you are decreasing the voltage, then the slip increases, then NR is equal to NS into 1 minus S. When the slip increases, one second, when the slip increases, the difference decreases and the speed of the motor will decrease, right? So this is a simple equation, right? So here can I say by keeping the supply frequency constant, if you are decreasing the voltage, the slip increases. When the slip increases, the speed of the motor decreases. Now let us just consider this. So what is the initial voltage I am applying here? 400 volts at what frequency? 50 hertz. Now let us assume I am decreasing the voltage to 300 volts. 300 volts. I am not changing the frequency. Frequency is how much here? 50 hertz. Right? Then what is the synchronous speed in this case? The synchronous speed ns2 is equal to 120 into f2 by p. So this will be same 1000 rpm. 1000 rpm. Then what is the value of nr2? nr2 is equal to ns2 into 1 minus s2. So what is unknown here? s2. So I'll use this equation. What is that? s1 into v1 square is equal to s2 into v2 square, that is 0.05 into 400 square is equal to how much into 300 square. If I solve this, how much, that is slip, that will be 0.088. If I substitute that, nr2 will be 1000 into 1 minus 0.088. If I solve this, it will be 912 rpm. 912 rpm. So like this, the questions will be asked. So how the question will be asked means, a 3-phase 400 volts 50 hertz induction motor, when it is excited with 400 volts and 50 hertz, it is operating at a speed of 950 rpm and it is driving a constant torque load. This is initial data. The speed of the motor is controlled by controlling the stator voltage. What will be the speed of the motor if the input voltage is reduced to 300 volts? Then you can apply this procedure, and from that, what is the answer? You can see here, the answer is 912 rpm. So like this, we can control the speed of an induction motor by changing the stator voltage. Now the question to me, right? So in the basic speed equation, you can see there is no like voltage term. But how we are going to control the speed of an induction motor by changing this stator voltage means, by changing the stator voltage, we are able to change the slip, and by changing the slip, we can change the speed of the motor. So this voltage control comes under which category of the speed control means? It is a slip control. By changing the voltage, we are controlling the slip of the motor, and by controlling the slip of the motor, we are able to control the speed of the motor. Like this, we are going to control the speed, right? It is a simple voltage control method. Like that, we can discuss many things. But very unfortunately, this voltage control suffers some disadvantages. What are those disadvantages means? The first disadvantage is, if you look into this slip equation, so here this equation says that if you are increasing the voltage, the slip will decrease. When slip decreases, this difference will increase and the speed of the motor can also be increased. So equation wise, it is very much true that we can control or we can increase the speed by increasing the voltage. But very unfortunately, it is not possible in practical. Why it is not possible in practical means, just one second. Why it is not possible in practical means, if you look into any nameplate details of a motor, so there will be a rated voltage. What is that rated voltage means? We are not supposed to apply a voltage beyond that value. Why? Because every machine will have a insulation around the conductors. So conductor and conductor are insulated by some insulation thickness. Conductor and core are insulated by some insulation thickness. So this insulation thickness depends upon the voltage what we are applying. So that is mentioned on the nameplate details. So it is an indirect communication from the manufacturer to the customer. My dear customer, when you are using this motor, please see that you are not applying a voltage more than rated or more than mentioned. Why? Because whatever that insulation I have coated can withstand the voltages up to whatever I have mentioned. Unfortunately, if you are applying a voltage beyond that, that insulation will get damaged, conductor and conductor will short, windings will get damaged. Please see that you are not supposed to apply a voltage more than rated. So here, that is the reason, if this equation says that is S is inversely proportional to voltage square, even if this equation says that by increasing the voltage, I can decrease the slip, and by decreasing the slip, I can increase the speed. So even if this equation says, then it is not at all possible in practical. Why? Because we cannot operate the motor beyond its rated. So this voltage control technique is applicable only for below rated speed, but it is not applicable for above rated speed. Right? So this voltage control technique is applicable only for below rated. Why? Because we can reduce the voltage, but we cannot increase the voltage, right? Second point is, it is only for below rated. The second point is, here, as you can see, we are increasing the slip, then what happened to the speed? Decreases. When the speed decreases, the relative speed between the field and the conductors will increase. So relative speed means Ns minus Nr will increase. So this relative speed will increase. When the relative speed between field and conductors, if it increases, then flux cutting the rotor conductors will also increase. When the flux cutting increases, the EMF induced in the rotor conductors will also increase. When EMF is increased, the rotor currents will increase, hence the stator currents will also increase. That means in this voltage control, the motor will draw high currents. Why the motor is drawing high currents? Whenever you are decreasing the voltage, the slip is increasing, the speed is decreasing, the relative speed between field and conductors are increasing, flux cutting the rotor conductors are increasing, current will increase. So the motor will draw high currents. That means the stator conductors, the stator windings and also the rotor windings will carry high currents. And if such high current flows in the windings, what happened to that ohmic losses, that is copper losses, increases. Because of this copper losses, what happened to the temperature? Increases. When the temperature increases, whatever the insulation we have coated around, sometimes it may not be in a position to withstand high temperatures because of that high current, and because of that high temperature, that insulation which is coated around will get melted. When it melted, conductor and conductor will short and windings will get damaged. So for that reason, I cannot operate this voltage control for longer time. It is only for short time. So can I conclude like this? Whenever you are decreasing the voltage, the motor draws high currents. Why? Whenever you are decreasing the voltage, slip is increasing, speed is decreasing, the relative speed between field and conductors are increasing, flux cutting the rotor conductors are increasing, EMF induced in the rotor conductors increases, current increases. So current in both the windings will increase, ohmic losses will increase, temperature will increase, and hence the windings will get damaged. And hence it is not applicable for long time operations, it is only for short time. So this voltage control is applicable only for short time application. So this is only for short time. Short time means I cannot use this voltage control for long time. It is only for short time operations. Short time operations. And third and very, very important thing is, as you can see, Ns is constant here. Why Ns is constant? The stator field speed is constant, poles and frequency are constant. Now if you are taking the rotor speed away from this, why? Because whenever you are decreasing the voltage, then what happened to the slip? Increases, then the speed is decreasing. So keeping this Ns constant, if you are taking this rotor speed away from Ns, then what happened? Again relative speed increases, flux cuttings will increases, currents will increase, ohmic losses will increase, temperature will increase, and hence we cannot use this for long time duration. It is only for short time, and in addition to that we cannot use this for wider range. It is only for narrow range. I can control the speed very closer to Ns. We cannot take the speed away from Ns. So it is only for narrow range, but is not for wider range. It is for narrow range. It is for narrow range of speed control. Narrow range of speed control. So these are some of the drawbacks what we are having with this voltage control. What is the first drawback, Baba? So here even the equation says that S is inversely proportional to V square. By increasing the voltage we can decrease the slip, and by decreasing the slip I can increase the speed. So it is not at all possible. Why? Because every motor will have a restriction with respect to the voltage what we are applying. We are not supposed to apply the voltage beyond rated which is meant. If you are trying to do that, that insulation will damage and windings will get damaged. So using this voltage control technique, it is not possible to get the speeds above rated. We can get the speeds only below rated. The second one is, so here whenever you are increasing the voltage, then obviously what happened to the slip? Decreases. What happened to the speed? Slip increases, speed decreases, the relative speed will increase, flux cuttings will increase, and hence the ohmic losses will increase. So this is not applicable for long time, it is only for short time operations. The next one is, it is only for narrow range, but it is not for wider range. Right? Why? Because I can control the speeds very close. Why can't I take it away from Ns? If you are taking away from Ns, the relative speed will increase, the flux cuttings will increase, and windings will get damaged in very short time. I cannot use for wider range, it is only for narrow range. So these are some drawbacks what we are having with voltage control. And this method I can use for both squirrel gauge as well as slip ring. So this method can be used. This method can be used for both squirrel gauge induction motors and slip ring induction motors. So this is something about voltage control. So please tell me, see, voltage control comes under which category? Means it comes under slip control. So by controlling slip, we are controlling the speed. So indirectly, we are controlling the slip. So by changing voltage, we are changing slip. By changing slip, we are changing the speed. Right? So these are something. Now let us take one more control. from rotor side. So just a brief, one more control. I'll try to take one more control from rotor side. So I'll try to take the rotor resistance control, one more, so that you can understand the difference. Rotor resistance control or rotor circuit resistance. Rotor circuit resistance, rotor circuit resistance control. Resistance control. In this rotor circuit resistance, I am not changing the original rotor resistance, but by adding some resistance, we are controlling the rotor circuit resistance. So by adding some resistance, the total rotor circuit resistance is varied. So here, voltage, frequency, poles, x2 naught and other parameters are kept constant. Now let us see by changing the resistance how to change the speed. If you look into this torque equation, electromagnetic torque is equal to 180 by 2 pi ns s v square by r2. So here you can see we are not changing frequency and poles. Ns will be constant, this will be constant. So we are not changing voltage, so voltage will be constant. As the motor is driving a constant torque load, then the motor torque should remain constant. If that is the case, S by R2 should remain constant. Should remain constant. If S by R2 should remain constant means S is directly proportional to R2. So here by adding some resistance, externally, I can increase the slip, and if you see this, NR is equal to NS into 1 minus S. So by increasing the slip, this difference will decrease, thereby I can decrease the rotor speed. So by adding the resistance in the rotor circuit, again we can vary the slip of the motor. Again by varying the slip, the speed of the motor can be varied. Now let us see a small example on this. After that we can go back. Now let us see what is the motor initially we have taken. So the initial resistance of the rotor winding, if you recall, it is 0.1. What is the speed at which it was operating? So NR1 is 950 RPM. 950 RPM. Let us consider I am adding an additional resistance of say 0.1 ohm externally. Then what will be the speed, right? Now let us see R21 is equal to R2 is equal to 0.1 ohm and R22 is equal to R2 plus R external, that is equal to 0.1 plus 0.1, it is 0.2 ohms. Then what is the relation here? S by R2 should remain constant. Then if that is the case, S1 by R21 is equal to S2 by R22. If that is the case, 0.05 S1 you have taken already. In this case, previously what is the value of S1? 0.05. The same numerical or the same problem I am taking. 0.5 by 0.1 is equal to how much by 0.2? So it is 2. So from this, what is the value of S2? S2 will be 0.2. Then from that, what will be the rotor speed? Rotor speed NR2 is equal to 1000. Why I am taking the same 1000 here? We are not changing frequency and poles, and hence NS will remain same. 1000 into 1 minus 0.1, it is how much? 900 RPM. So by adding an external resistance of 0.1 in the rotor circuit, so we can reduce the speed from 950 RPM to 900 RPM. But here the point to be noted is, so this is applicable only for a slip ring induction motor. Why? Because in case of squirrel cage, we don't have any provision to vary the rotor circuit resistance. Why? Because you people are aware that in case of a squirrel cage motor, the either side of the rotor bars are short circuited with end rings, as it is connected with end rings. So we don't have the provision of changing the external rest circuit or the rotor circuit resistance. So this is applicable only for slip ring. How the question will be asked in this? So a three-phase induction motor is having the rotor winding resistance of 0.1 and it is operating at a speed of 950 rpm. When it is excited with a 400 volts 50 hertz supply and it is driving a constant torque load. What will be the speed of the motor if an external resistance of 0.1 is added in the rotor circuit? So in this case, what is that external resistance? So it is 0.1, then what will be the speed of the motor? Means it will be 900 rpm. I hope you understood this. So this is some simple concepts, right, which you can apply directly. So I have taken the torque equation and I have seen which parameters are constant and which parameters are varying. Then accordingly we brought out some relation and finally we are able to solve the numerical. So even this rotor circuit resistance or rotor rheostat control resistance or rotor rheostat control is applicable only for slip ring. Why? Because only in case of slip ring we can vary the rotor circuit. Now let us see the drawbacks of this. Why? Because in competitive examination people will ask the drawbacks also, right? What are the drawbacks? So here if you look into this equation, S is directly proportional to R2 plus R external. So we have the provision of only adding resistance. I can add resistance, but I cannot subtract resistance. When I cannot subtract resistance, I cannot decrease the slip. So here in case of rotor circuit control or rotor resistance control, I can add only resistance and I can increase only the slip. I cannot decrease the slip, I cannot reduce the slip. So here we can only increase the slip, but we cannot decrease the slip. When we are increasing the slip, we can decrease only the speed. So here we can get the speeds below rated but not above rated. So in this rotor circuit resistance control, we can get the speeds below rated or we can control the speeds below rated. We cannot control the speeds above rated. The second thing is, as you can see, by adding resistance, we are increasing the slip. By increasing the slip, we are decreasing the speed. When we are decreasing the speed, the relative speed between field and conductors will increase. Flux cutting the rotor conductors will increase. EMF induced in the rotor conductors will increase. Current will increase. Ohmic losses will increase. Temperature will increase and windings will get damaged. Why? Because once the temperature increases, the insulation will get melt. Once the insulation get melts, the windings will get damaged. So this is not applicable for long time. Again, it is applicable for short time. So this method is applicable only for short time, right? So what is the first one? So below rated speeds. Below rated speeds. Second one is short time applications. Third one is, here again NS is constant. As NS is constant, we cannot take the NR away from NS. Why NS is constant here? Frequency and poles are constant. NS is constant. We cannot take NR away from NS. As you are taking NR away from NS, what happened to the flux cuttings? Damages. The flux cuttings will increase, EMF will increase, current will increase, ohmic losses will increase, the temperature will increase and windings will get damaged. So here using this method, we cannot take the rotor speed away. The rotor speed should be closer to NS. So I hope it is clear. So this is something about your rotor resistance control techniques, right? I hope you understood, right? So before we conclude this, before we stop our session, so again just some points. First one is how to prepare the strategy, preparation strategy. Make your mindset strong, physical strength strong, physically strong. Then go through the syllabus thoroughly. Please go through the pattern thoroughly. Keep some reference textbooks particularly. Make a timetable. calculate the number of days, calculate the number of hours supply available, allot the timing for the particular subject, particular topic, complete the chapters in time, revise each and every time. Before you attempt the examination, you have to revise the subject thrice or twice. Then while you are preparing, you have to prepare a short notes and keep that short note available for your last minute preparation. Then give more number of mock tests, right? Even if you are not prepared for the mock test, please attempt the mock test. Attempt. If you are not prepared, commit mistakes, give wrong answers. If you are right, happy. If you are wrong, give the wrong answers. Learn from the mistake. Don't repeat the mistake again. Then finally start your exam preparation and get ready with the examination. I hope you are clear with this, right? Thank you. I wish you all the best. Take care, right? Bye.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of.
Right. Sorry, my dear student, there was some technical error previously. So one of the student has a doubt. What does that means? Sir, what about this AP, Andhra Pradesh state-wise electricity board exams? So very soon, even for Andhra Pradesh also, we are going to have this notification. I cannot say 100%. The chances are more, around 90%. When I say 90%, the chances are more only, right? So the chances are more, there will be a notification even for Andhra Pradesh also. So the bad thing in the student mentality is they will wait for the notification. Don't wait for the notification. It is sure that the notification will come for sure. So please try to start your preparation right now, today itself, and try to fix the timetable for 3 months and try to start your preparation. Once you start your preparation, then you can see if it is coming tomorrow, then it is enough. Even if it is coming after 3 months, you can repeat your preparation, then you can make yourself strong for the examination. So 100% for Andhra Pradesh also, State Electricity Board, again I cannot say 100%, 90% chances are there, surely, right? Why? Because most of our students are working in the statewide the State Electricity Board. So just may not be 100%. They say, sir, chances are more that the notification is going to be released soon. So unofficially, I used to get some information that maybe, right, released soon. So please start your preparation. Don't wait for the notification, right? I wish you all the best, right? Thank you.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my